So, thanks. Welcome everyone to the panel of civil servants. Today we have 3 presentations. So each one will last 25 minutes, and then we have 5 minutes of questions and answers. So first, we have Grace Armijos.
Yes. Okay. Good morning, everyone. I'm going to share my slides. Okay. So let me. Okay. Okay. So today I'm going to present a joint work with Judith Val on job competition in civil servant public examinations and sick leave behavior. Okay. So
Grace, can you maximize?
Oh yes. I forgot, but you're right. Okay. Yeah. So in several countries, the entry system to access permanent civil servant positions relies on the traditional process of formal public examinations. Okay. So these type of positions are very attractive as they offer long-term employment stability, better working conditions, for example, vacation days, labor conciliation policies, working hours, and in particular, as I mentioned, they offer long-term employment stability. So this make this type of positions very attractive and encourage individuals to participate. To give an idea of this situation, for example, in recent years in Spain, for a call of around 4,000 positions, there were more than 80,000 participants. And this is a picture of how these type of examinations looks like. Okay, so in here we have in Spanish, in Spain it's called the oposiciones, which is a public examination to access the education sector, to access a place in the education sector. As you can see, it's a huge amount of individuals taking these exams. Okay, so to access these civil servant positions, individuals have to take an examination. And this type of examinations demands a lot of time to prepare for the exam. It's not something that you can just go tomorrow and then you are going to pass. No, it's something that you require and that you need to really prepare yourself. Okay, so our idea is that this may influence the sickness status of the participant, having a special attention to individuals that are currently working and that has to combine both working and preparing for the exam. Okay, so we think that maybe these employees might fall in sick as a negative consequence of the hard process. And this, of course, is going to be translated into cost for the sickness insurance system. Okay. So what we want to do in here is identify whether public examinations have an impact on sick leave behavior in Spain. How? Well, in terms of increased sickness absence as a negative consequence or as a negative externality of the civil servant recruitment process. That is what we want to do in here. So regarding the relevant literature on public examination as a selection process, research has focused more on the psychological and personal management field, going around better practice to manage the process. And in economics, there is a scarce research conducted. For instance, we have some documents there are some documents from Manuel Bagués and co-authors regarding also Spain. Okay, so to our knowledge, there is very scarce or new literature on the consequences that the selection process might have on participants' health. Okay, so the main contribution is to assess whether the recruitment system induces negative externalities in terms of increased health-related work absence. Okay, being the mechanism behind maybe an increase in stress among applicants who are combining both work and exam preparation. So what data set we use to try to see what's going on, to see if something is going on in here. Okay, so we use, first of all, administrative data from the Social Security Administration of Spain on the universe of sickness absence for years 2009 to 2015. We are using administrative records for the whole population. We are not working with a sample. Okay, so in here we have the information about common illnesses. We are exploring changes in common illness, okay? No in other type of sick leave. We have information on the month and year of birth and gender of the individual, the start and end date of the sickness episode, and the illness that causes this sickness. We also have the information about the province, the firm's economic activity, and with the information on the firm's economic activity, we split the sample and construct 3 different subsamples with individuals working exclusively for the public administration, for the education, and for the health sector separately, okay? And regarding the recruitment exams data, well, we constructed the data from administrative records from the institution that is in charge of managing the civil servant positions offer, also for the same years. And we have information on all calls for positions in Spain with information on the date of publication, the examination date, the type of position, the number of positions within every call. And we have also information on the institution that is providing or announcing the call. And in here, we also classify the institutions according to the 3 economic sectors already mentioned, the public administration, the health, and the education sector. And we also use information from the Spanish Labor Force Service to derive the number of workers per period and economic sector. Okay, so among all these data, all this information, we select or we choose to work with what we call the sample definition. Okay, we focus only on regional and local positions because these are the positions in which we can identify the province in which individuals are going to work. In the general positions, the ones that are at the national level, we do not have information on the location of the position. Okay, and we also are focusing on sick leave episodes from individuals contributing to the general contribution scheme. There are other schemes of social contribution in Spain, and we also focus on individuals within the working age population, that is between 16 and 65 years old. We also exclude all temporal contracts in the calls data because this type of contracts, they do not require a public exam to access. In temporal contracts, you access through other mechanisms, okay? So with this, we collapse our data set by province and month of year in a way that we get a balanced panels of provinces. And as I mentioned before, we split the sample into 3 economic sectors, okay? Public administration, education, and health sector. Okay, so what is our main empirical strategy to see what's going on in here? Okay, so we apply an event study design, a generalized event study design, to see how these spells behave before the examination date. So we want to see what happened with sick leave episodes before the exam, because our idea is that individuals may fall in sick before the exam, as they have to combine this working and preparation for the exam. Okay, so this is our estimated equation in which we have 2 outcomes of interest. First of all, the total number of spells per working population and the mean duration of the sickness episode. And our variables of interest are this set of dummy variables that capture how sick leave behave months before the exam, okay? And we cluster our standard errors at the province levels, and we also include some fixed effects. We also set the reference period at 7 months before the exam. So the decision to set the reference category is not very straightforward. You know, the event study literature suggests to set the reference period 1 month before in a classical treatment or untreated setting. The suggestion is to set the reference category 1 more period to the treatment. Okay, so in here, our treatment is to put a word. Okay, the treatment or the effect that we want to see is before the exam. So all the things we expect to happen between the moment of the call and the examination date. So this 7 months is like an average of this time between the moment of the call and the examination date. Okay, so we have all type of positions in here, but we think that, well, also based on some literature, we define what type of positions we are going to consider. We are in a first attempt, we work only with large number of positions. That is, with calls that have a high number of positions. Sick leave behavior might not respond to a small number of positions. Okay, so in this sense, the perceived probability of winning the place is higher when more positions are available. We have a robustness check on this issue later. Okay, so to see the preliminary results we have so far, and here we have the extensive outcome. The total, we can say the absence rate per 1,000 workers, and we have every color represents a different economic sector. And overall, we can see that we get a significant increase in the total number of spells or in the absence rate month before the examination date across all the economic sectors, in particular for individuals working for the public administration sector and in the health sector. Okay. So regarding the intensive margin, that is the duration of the sickness absence, we find variation, detrimental variation in the average mean duration of these sickness episodes for individuals working in the education sector. For instance, 3 months before the exam, the average mean duration of this sickness absence can reach up to 6 days. Okay. We also go a step further and try to see where this variation is coming from regarding the conditions or the illnesses that are causing these sick episodes. So we decide to divide conditions according to a classification. I don't remember right now the reference, but it's we have a reference for doing this. Whether the conditions are more subjectively conditions or conditions that can be diagnosed through objective tests. For instance, conditions that are not very objectively diagnosed, we have mental conditions. In here we have anxiety, depression, feeling stressed, feeling tired, osteoarticular condition, which is mainly composed in our sample by individuals suffering or declaring to have back pain, neck pain, and digestive conditions coming not from an infectious disease. Okay, so in here we see that we also find an increase in the absence rate for individuals working in the public administration sector, which is the blue lines, and also for individuals working in the education sector. So as a summary of the results, we find some evidence supporting an increase in health-related absence month before the examination date. We find this for the public administration sector, for the education sector, and also in the health sector when we are analyzing the absence rate. When we move to the average mean duration, we also find some detrimental effects in the education sector. And we also perform a gender heterogeneity analysis that I'm not showing here due to time constraints. But in here, we find mixed evidence on whether women or men are more responsive in terms of sick-related work absence in face of large calls for positions, okay? So we also perform some robustness checks that I'm not going to show here in detail, but we change the treatment event variable as continuous. In here, what we do is instead of treating the calls as a dummy, we use all the variation in the number of positions announced, okay, in every call. And we get very consistent results. We also change what we call the treatment definition. Instead of using the largest call, we give more space to include other type of positions, and we also get consistent results. And we also perform placebo illness tests in which we focus only on conditions that are 100% diagnosed through an objective test. That is the tumors or neoplasms. Okay, so in here we should not find any variation, and that's what we find. We don't find any variation in sickness absence coming from this type of positions. And a next question that comes to our mind was, okay, so we find this increase in this supporting evidence in in increasing health-related work absence. So we want to see if there is something going on in public administration workers' health. Okay, so for this we use data from a survey called the Barómetro Sanitario, which is conducted on a regular basis in Spain, that has information on self-assessed health and healthcare use. And in here we estimate a regression interacting a dummy of individuals working in the public sector in Spain compared to individuals working in the private sector, and also with a dummy variable capturing large calls in the province of residence of the respondent. Okay, so in here we can add some socio-demographic controls like sex, age group, and socioeconomic status. And we explore some outcomes like the probability of visiting the general practitioner, the probability of reporting bad health, the number of general practitioner visits, and the number of specialist visits. Okay, so here is a preview of these results. In here we are comparing individuals working in the public sector compared to individuals working in private sectors. Okay, so here we find that there is an increase in the probability of visiting the general practitioner, also visiting the specialist. We don't find a significant variation in self-assessed health. However, we find a coefficient with expected sign. And we also find an expected signs in the number of general practitioner visits, conditional on having visited the GP, and also in the specialist, though significant only at the 10% level. So this make us think that whether this is a supporting evidence that there is some probability that public administration's workers' health might be negatively affected by this type of public examination. So this is this evidence is not causal, this one from the Barómetro Sanitario, but I think that adds some evidence supporting this relation. Okay, so in this part of the workers' health analysis, we also perform a gender heterogeneity analysis, and in here we find that women seem to be experiencing more visits to specialists compared to men, while men are reporting more probability of visiting the GP compared to women. And an additional concern in here might be that that we should not expect permanent workers to be experiencing detrimental health effects, right? Because our permanent workers are already with their permanent position in the workforce. So we should expect to see this effect or this result coming from individuals under temporal contracts that now are both working and preparing for exams. So we focus on a subsample of public sector workers and compare temporal versus permanent workers in the public administration sector. And we find that being a temporal worker is associated with an increase in healthcare use and in the probability of reporting bad health compared to permanent workers in face of large number of positions in their province of residence. Okay, so excuse me, as a conclusion, so we have found evidence that calls with a large number of positions produce higher impacts in terms of absence rates. And we also find that education sector seems to show the stronger effects in sickness absence. So we also have evidence suggesting that what we call the subjective conditions may be driving this increased number in sickness spells. And we also have some evidence pointing to worse health among public sector employees with a particular detrimental condition in temporal workers. And of course, this is of important policy implications, as this is generating negative externalities that also can be translated into productivity losses in the workforce. So thank you very much. I think I'm on time, and that's what I have prepared for today. Thank you very much. I don't know if I have a minute or 2 minutes to comment some questions that are in the chat, or shall we pass to the next presenter? Or
William, I think
we cannot hear you.
Yeah.
William, I was asking
Sorry,
whether...
yes, I was muted. I apologize. So yes, we have enough minutes. So we have like 5 to 10 minutes for questions and answers. So there are 2 questions in the chat. So Jairo, he's saying, I don't know if aggregated data is accurate to obtain inferences at individual level. It looks like a micro phenomenon. And I had a similar question that you aggregate at the month level, but it seems that you can also look at the like weekly level or even more disaggregate data.
Yes, I agree with you, William, and also with Jairo. As I mentioned, this is our first attempt. We are first exploring at the monthly level, but we have, as we have high frequency data, we can also explore at the week level to see what's happening in a shorter time horizon. And regarding Fernanda comments, she says that can individuals declare themselves sick just to have more time to study for the exam? Yes, that is also another possibility. We have in our mind these 2 possibilities. First of all, that individuals are really falling sick, they are stressing, and they are experiencing this detrimental health, but also that individuals may be using the sick leave as a strategy to gain more days to study. Okay, so we are trying to rule out these 2 possibilities, and we managed to find this data on sickness absence to see if we find something related to health, but we know, and we have this possibility, and in the paper we are now trying to find a way to disentangle or to rule out which mechanism is behind this increase in sickness absence. But thank you, we agree with you. And then Jairo says, what if there was another event simultaneously with the exam date? Like, for example, what are you thinking about, Jairo? Or what is your idea about that question, Jairo, if you want to comment?
Sorry, I was just asking about another event occurring simultaneously with the exam date. I mean, that could have affected the result. I mean, I don't know, maybe there are another events. I can understand why, because it is a very specific case, and I don't know about anything about the condition about the experiment.
Okay, yes, that might be that possibility. We are including some fixed effects that we hope that can capture some variation at the province level and at the time level, at the month, year level, to hopefully try to uncover some of these things. And but yes, you're right, and we have to think more about this. Thank you for your comments.
Yeah, in that case, it would be just, I mean, this doesn't need data so much, but rather than explain why there were not another events that possibly can affect results. I mean, this is more that, or anecdotally reference that are needed, and I would say that's okay.
Okay, thank you. I couldn't understand very well your voice. I don't know. Maybe it's my audio or your microphone, but I couldn't understand very well your last part. But thank you very much for your comment, and we are going to take them all into account.
Grace, can I have just 30 seconds or something? Yeah. So maybe in terms of Fernanda's questions about how do we interpret the effect that you're finding, right? So maybe if you have the admin data on all workers, and if you have the performance measure, maybe you can associate. I mean, it's going to be hard to identify, but you can associate, you know, sick leaves and their effects, or association, correlation with, you know, performance on the test. Like, so you can test the hypothesis that, you know, workers who have more sickness of absence can have better outcomes in that test. Maybe that, you know, can shed some lights on that.
Thank you, Jorge. That's a good idea to try to find at least associations on this. Thank you, Jorge.
I think at least for teachers, you can estimate like their value added.
I was thinking just about the teaching economic sector. We can find something in this, at least for this group of workers.
I cannot hear you. Is it me or?
Let me see. I think
it's just you. Yeah.
Okay, William. I was saying that we also were thinking about the education sector, like as a sector in which we can explore somehow productivity, to try to give an association in line with what Jorge said.
Excellent.
Thank you very much.
We have 2 more minutes. Another question that I had is one is in the estimates, I see that the education sector, the standard errors are smaller than the other ones. Is it because you have many more teachers than
it's probably, yeah. Okay. I think that can be the case. Yes.
And the reason why you divided into like those 3 different sectors, it wasn't clear for me. Could you tell us?
We have in the paper, we don't have yet the estimation, but we also have the estimation like for the whole sample without splitting the sample. Okay. But we thought it was maybe a good idea to split the sample, because in this way, we can more accurately identify the groups, because all in the calls data, the positions are for individuals working under what is called in Spain public administration sector and health and education. There is no possibility, any other possibility. But in the sick leave behavior data, you have all individuals contributing to social security. So you have individuals working in private sectors, in public administration, and on all the economic sectors. So we try to see what happened exclusively for individuals working in these 3 sectors, to try to match in a more accurate way both samples. But we also have estimates for the whole sample.
Excellent. Thank you so much, Grace. Next is Jorge Rodriguez. The floor is yours. You have 25 minutes.
Okay, thank you, William. Thanks everyone for being here. So this is a joint work with Patricia Araya from University of Los Andes, Chile, Dante Contreras, University of Chile, and Paulina Sepúlveda from the Ministry of Education. So, so there's an increasing use of pay-for-performance schedules in the education sector. That's increasingly common, right? And the idea of these systems, you might already know, is that the system associate teacher salaries to student performance, right? And to performance in a series of standardized exams, for example. So the focus on this system, which is of course very inspired by agency theory, is to pay for the output of the educational process. On the other hand, in education, there's a long-standing tradition of professional development systems and teaching evaluation systems. And the idea here, instead of focusing on outputs, is on inputs, like the inputs in the educational process, which in this case is how well the teacher teaches and teachers' human capital. So in this paper, we basically ask, what are the merits of combining these 2 systems? So what if we, instead paying by the output, we pay by the input? Instead of incentivizing through payments on student performance, we directly incentivize teachers for increasing their human capital, right? So instead of paying by the output, pay by the input. So in this paper, more specifically, we assess the effects of a pay-for-performance system, which is tied to professional development in Chile. And this is a large-scale, nationwide reform that is called Carrera Docente. The translation of that is literally like teaching career, okay, Carrera Docente. And the idea is that teacher payments were associated with teacher evaluation measures, okay? As I said, it's a nationwide reform that fundamentally changed how public school teachers were getting paid. So we're gonna use admin data on teacher record and student test score. We have a very large admin data on the universe of teachers and students, and we're going to exploit the fact that the program was implemented gradually across different groups of teachers in different points in time. And we'll exploit that setting in a very simple different model. I'm going to show you next, and to assess the effects of the implementation of Carrera Docente on student test scores. So in a nutshell, our results are following. Our main specification shows that the effect of this nationwide reform is basically zero on students' performance, okay? And we estimate a really precise zero, okay? A really precise null effect, okay? So that's bad news in terms of the public policy. Nonetheless, we do find some heterogeneity in the effects of the program. In particular, we find that students associated with teachers who are facing the largest monetary rewards for the marginal improvement in their performance, those students are getting the better results, right? And I'm going to explain in a minute. The system is not really linear in the sense that the system does not give the same incentives for every teacher. So some teachers, they get a larger reward for their performance. Some teachers really get, relatively low marginal benefits for the additional effort in performing well. So this heterogeneity motivates a structural approach in which we ask, can we make a better system? In the sense, can we make incentives more homogeneous across the distribution of teachers? And can we improve the effectiveness of the program, right? So they don't have time in this presentation to give you all the details, but the main result is that through counterfactual policy simulations, we find that relatively simple modifications of the program can increase the effectiveness of Carrera Docente. Okay, so that's the idea of the paper. So let me give you a brief overview of Carrera Docente. Before that, so we can get an idea of the counterfactual sort of scenario. So before Carrera Docente, teacher salaries were mainly unresponsive to any type of performance. So there was a large component of a baseline salary, which was fixed, and there's an experience component, and there were incentives though. I mean, it's not like they had no incentive whatsoever, but those incentives were associated with relatively small monetary payments compared to Carrera Docente, right? So Carrera Docente, the idea is that teachers are placed in different performance categories, right? So, a beginner and expert, that's the idea. And these performance categories determine different payments, okay? So you can see a rough idea of the system and the magnitude of the monetary payments in this figure. So the idea here is that the blue line shows Carrera Docente, the red line shows without Carrera Docente, or the previous or the all salary scheme, right? So placement in these 5 categories, from initial to expert number 2, is based on 2 things. First, experience. So you can see here in the x-axis. So in order to be, for example, in the expert 2 category, which is obviously associated with the largest monetary reward, you need to have at least 16 years of experience in the teaching sector. So that's one condition. And the second condition, you need to perform relatively well in 2 measures of teaching on a teaching evaluation system that I'm going to explain in a minute. Now, this is what's important here. This is a progressive system. So suppose you you start on the initial category, you cannot jump right to expert 2, right? You need to go through every single stage in between in order to be an expert 2. Okay. So another thing that's important in this figure is that obviously older teachers, they have large incentives for the marginal, increase in their effort, right? This is going to be important to interpret the results in 5 minutes. So as I said, the placement in these performance categories were based on 2 measures of teacher human capital, so to speak. The first is the pedagogical knowledge test, PKT, and the idea is that it captures how well the teacher knows the subject she's teaching. So this is a math teacher. The PKT measures math skills or math knowledge, okay? And then the portfolio measures how well the teacher teaches. So conditional on having certain knowledge, how well the teacher transmits, how well the teacher teaches the knowledge she has to students, right? So there's 2 types of skills, right? How well the teacher teaches, how much the teacher knows the subject, okay? So a little bit of data and some context as well. So we have—
Jorge, a quick question. So do you know what are the weights for each of those 2 components? Are they like 50-50 or one is?
It's a tricky question, because the idea is that, so in order to, for example, to get, and it's a good question. So in order to say you're in advanced category and you need to, or you can advance to expert 1, right? So that's your goal. So you either, so you need to perform well, so a minimum cutoff, either on portfolio or a PKT. So you have these 2 alternatives, right? You need to perform well in either one of these 2 tests, right? It's a very complicated system. So in that sense, the weights are the same, right? In the sense that you can be an expert 1 conditional on having the years of experience. You can be an expert 1 in 2 ways. You can perform well in PKT or in portfolio. Okay. So in terms of data, we have the administered teacher records from 2005 to 2017, and we know in which classroom the teacher taught in every point in time. We also have teacher characteristics, and of course we have the measures of teacher performance, PKT and portfolio, and we were able to link that data set to students' administrative data. So we know basically where the teacher taught and to which students, right? And every point in time. And in terms of students, we have their performance in a standardized test score called SIMSE. So SIMSE evaluates students in math and language, and this is as I was saying, a standardized test that is comparable across time. We also have different information on student characteristics, parental education, income, and so on. So more context here. So Carrera Docente was implemented in 2016. Okay, not all teachers entered the program right away in 2016. So different group of teachers are being evaluated in different years. So there's a first cohort of teachers, and this is going to be my treatment group that was evaluated in 2016. There's a second group of teachers that was evaluated in 2017, and so on. Okay. So as I was saying, my treatment group is going to be the teachers who were evaluated right away the implementation of the program. My control group is going to be those teachers who are evaluated in 2018 and beyond. And I'm going to exclude from my analysis, at least from my our preferred specification, the 2017 group. And the main reason is because we want to avoid a violation of the no anticipation condition in the context of a different diff model. So what's that condition says? It says that in the context of this sort of setting. So in 2016, every teacher knew when they were going to be evaluated. So in 2016, the second cohort knew that they were going to be evaluated in 2017. So they could have anticipated, the treatment timing and start changing their behavior from before. So if that happens, it's a violation of the no-anticipation condition in the standard definitive model. We want to avoid that, so that's why we exclude that group altogether, right? So in this setting, then we have, given that we have only data on SIMSE, the student sector until 2017, we only have one treatment group and one control group. So this is a very simple diff and diff specification in which the regression, the linear regression you see on the screen will identify the effects of the program on those students associated with teachers who were evaluated in 2016. That is the average treatment on the treated, right? And this is, of course, conditional on the parallel trend assumption, which says that the difference between students associated with teachers in the treatment and control group, the difference in their counterfactual outcomes are constant in time. And that's so conditional on that assumption. The regression you see on the screen, the estimate on beta 3 will identify the effects of Carrera Center. So first result, we find, so good news in terms of my paper is that we find no pre-trends. And this is a very robust result, given that we have a lot of previous periods before the implementation of Carrera Docente, both in math and language. But the bad news from the public policy point of view is that we find no effects after the implementation of the program. And our different diff coefficients, here in blue and here in yellow, of math and language, are really close to zero and very precisely estimated. So, and this is also, we try different things and different robustness checks. We find very consistent effects that, or very consistent evidence that the effects are really, really close to zero. Okay, so first of all, one might think, well, teachers are not responding to incentives, but the following evidence, the evidence I'm going to show you right now, does not support that hypothesis. So first, we find that more experienced teachers are the ones who are associated with positive and statistically significant effect on students. And recall that all the teachers were facing the largest monetary payments from the system. And so this evidence is consistent with that, right? And second of all, what we do here is that, as I was telling William, so what we did here is that we take previous test scores. So every teacher, as part of the old system, had some PKT and portfolio measures from the old system, the low stake system, if you. So we take those test scores and we compute the distance to the nearest cutoff in the new system, right? And this is the cutoff to advance to the next category, right? And we wanna see if that there are heterogeneous effect across distance to the nearest cutoff. And we find that we do find effects, and we found this even though some of the coefficients are not significant, but we do find this in very U shape, which is very consistent with a model I'm going to show you in a minute. In a model in which a teacher must to choose her optimal effort to learn these new skills based on how far or how close she is to the nearest cutoff. So if the teacher is really close to meeting the minimum threshold to advance to the next category, or is already beyond the cutoff in terms of their previous skills or baseline skills, then she won't provide much effort because she knows she's going to pass the exam no matter what, right? And these are the effects that are like in the first quantile of distance to the nearest curve. The same goes, the same result follows for teachers who are really far from the cutoff, right? If from some teachers, her baseline skills are so low that the marginal cost to pass the exam is so high that they won't provide any effort. So we find, like, consistent with that model, we find that teachers who are midway of meeting the cutoff, which makes sense in terms of this economic model, we found that those teachers are associated with effects on student test scores, right? So this heterogeneity in the effects gives us sort of a clue in the sense that we can design a system, a better system that can increase the effectiveness on students' test score, given the fact that the current design of the program, which makes that some teachers are not getting enough incentives to increase their effort, is holding back, right, the possibility of producing more learning in students, right? So we, as I was saying, so the idea here is that, estimate structural model and simulate policy that make incentives to teachers more homogeneous across the distribution of teachers. And then we're going to see what happens in those types of systems. So before doing that, we need to set up our structural model. And this is a very sort of simple agency model that is accommodated to our setting here. And the idea is that the teacher maximizes their effort. And there are two types of effort here: effort toward learning the portfolio and effort toward sort of mastering the skills associated with the PKT, right? So how well the teacher teaches, how well the teacher knows the subject she's teaching, right? And so what are the trade-offs here? So if you increase effort in these two types of skills, it's going to be directly affecting utility, possibly in a negative way, but also directly through student achievement. So if you have more effort in learning these teaching skills, you're probably going to produce more student human capital. You're going to produce more, you're also going to produce more test scores, so you're going to perform better in your teacher test scores, and that can increase your earnings, conditional of being on the treatment group. So that's the idea of the model. So there are a lot of functional form and distributional assumptions that allows me to estimate the model, right? So I have like 2 or 5 minutes, I think.
5 minutes.
5 minutes. So I'm not going to give you every detail of the model, but that's the idea. So I estimate the model. And so a couple of things that are important before showing the results, that in the model, we find that effort towards learning those skills increases both teacher test scores and students test scores. So that's important because it means that these measures, portfolio and PKT, are actually very aligned to students' human capital. And that gives us the opportunity to try to sort of redesign the system and think about other policy configurations that can increase the effectiveness of carrera docente. Another thing that is important is that our model is able to reproduce really closely the effect of the program as it is, right? So my model predicts an effect on student test scores that is very close to what the diff and diff specification finds. So this is good news. It means that the model is actually able to really have a good approximation of counterfactual effects or counterfactual policies, and that gives us confidence. Gives us confidence in the sense that we can think about modifications of the policy, and we can have reliable effects or simulated effects of different types of policies or different versions of carrera docente, right? So the first contrafactual policy is going to be a carrera docente, but we remove the experience condition. So you don't need to have a certain amount of experience in order to be in a certain performance category, right? So that's going to be a first contrafactual. In a second contrafactual exercise, we're going to remove the experience condition, and we're going to remove also the fact that payments are based on categories, and we're going to simulate the effects of the program that basically is a linear pay for performance system, right? So, and here the idea is that the teacher salary is going to be a linear function of the simple average of the two tests. Yeah, simple as that, right? So in this way, every teacher has sort of the same incentive to increase a similar marginal benefit from increasing the portfolio or PKT test score. So in terms of the first, so I have like 2 minutes. So let me go through the result very quickly. We do find, so first of all, we do find that a system that removes the experience condition increases student achievement, and it doubles the effectiveness of the program in terms of student test score effects. And those effects come mainly for teachers who have less experience in the teaching sector. That's one result. And the second, potentially more powerful result is that if we think about a more simple system without the experience requirement, without the performance categories, and so without these hard cutoffs that determine payments, and we think about a linear system, we can have much larger effects on students' human capital, right? So there are a lot of details like in the background. I'm happy to discuss them in the Q&A. But just concluding, we study the effects of a large-scale reform in Chile that fundamentally changed how public school teachers were getting paid. We find that that program has null effect on average, but we do find heterogeneous effects, suggesting that teachers are responding to incentives, but probably the program is not optimally designed to incentivize all teachers in the same way. And through contrafactual experiments coming from a structural model, we find that reconfigurations of the program can actually increase the effectiveness of carrera docente. So that's it. Thank you.
Excellent. Thank you so much. Very interesting paper. So now we have 5 minutes for questions. So since I have a basic question, I think I didn't, probably I missed it. So you have a control group because this program was implemented in certain areas, or I thought it was implemented nationwide.
It was implemented nationwide, but okay, here. So it was implemented nationwide, but not all teachers were evaluated at the same time. So in 2016, a first cohort of teachers, so they implemented the program, and then months later, this group of teachers was evaluated in PKT and portfolio measure. So they had like all this time to study and to increase their teaching capacity, and I want to capture the effect of that, right?
Okay.
And I want to compare those students associated with those teachers with students taught by teachers who are being evaluated further along in the future, right? So those teachers do not have the incentive to study right away because they're going to be evaluated like in 2 or 3 years ahead, right? So that's the intuition.
And these teachers were selected randomly, or did they apply to be
Good question.
evaluated?
No, they were not. So there are differences. So groups are not randomized whatsoever. So for example, the 2016 teacher, they have less experience, and they have a little less portfolio score. So they are the groups are not randomly assigned. So if they were, I wouldn't be estimating the differently, right?
Mhm.
But they were not self-selected in this group. So the education authority just basically picked according to, for example, so what they did is that they say, okay, so we're going to, like in this year, we're going to evaluate first grade and until they say fourth grade teachers in math and music teachers and language teachers. So I'm making this up, but that was the idea. So the groups are different, but they were not self-selected, and they were not selected based on previous performance or anything like that. Yeah.
Great.
Can I have it's just a clarification? Yes, Jorge, a very good presentation and interesting paper. I have a clarification question. I guess this is for Chile, right? So in Chile, the composition also is a majority women, right? Teachers are mostly women, I think.
Yeah.
Okay, yeah, and then you said that on average you don't find any effect of the policy, but that there are some groups in which you do find some effect. Can you remind me what groups are those in which you find?
Right, so
I don't remember.
More experienced teachers.
Okay.
And teachers who, based on their previous test score, are sort of halfway of meeting the minimum threshold to advance to the next category.
Yeah. Okay. So that make me think that maybe, as you said, no, and I think this goes beyond your paper.
Right.
Maybe the design of the policy should be focusing on what stage of the teacher career you are in the moment this policy was implemented. But I think that new teachers are going to begin in the first stage, right?
Yeah.
So maybe the incentive for teachers that are just beginning in the career are different for those that are in the in the last stage. So I think this paper is it's very interesting because it's something that for sure it's very policy relevant and may.
Yeah.
I was thinking next paper for this should be how to design a better policy that indeed benefits all groups of teachers,
Right.
which in turn is going to benefit the students at the end.
Yeah, well, thanks for your comment. Yeah, and that's actually what we wanted to sort of achieve with the second part of the paper, the structural part. Of course, there are a lot of assumptions behind it, but we at least wanted to get a sense of can we make a better system? Now, this is all conditional on teachers, a union accepting those changes. So it's going to be difficult, but and the design of the program was very conditional on that. But yeah, I agree with your comments. Thank you.
Okay. And one last comment before I present is that have you done the graph that you're showing us right now? Have you done that by experience? Since those who have high experience, they have higher incentive to put more effort. So probably the distance. I mean doing the interaction between experience and distance. So maybe those with a lot of experience, there's an effect with longer distance. I don't know if you understand me, but doing it like a two-way.
We haven't done that, but that's interesting. Let's see. Sample size could be tricky, but but let's see. Yeah, it's an interesting exercise. Thank you.
Okay, thank you so much, Jorge. So the next presentation is me. Do you mind to unshare? Okay. Okay. So, well, my name is William Delgado, and I'm at the Boston University. Feel free to interrupt me if you have any questions, or you can, write in the chat or ask later. So this paper is Heterogeneous Teacher Effects, Comparative Advantage and Match Quality. In this paper, I derive a novel measure of teacher quality that can help us close achievement gaps. So why is that important? Can you guys see my presentation? Yes, okay. So racial, gender, and income achievement gaps are a persistent and a stubborn fact in the US and around the world. And we know that observed disparities in adult outcomes, such as the racial gap in earnings, the gender gap in STEM fields, and SES gap in college enrollment, and other disparities are greatly reduced after accounting for achievement gaps. And we know also that teachers play an important role in improving student achievement and also later life outcomes. However, we know little whether and to what extent teachers close or widen those achievement gaps. And this paper aims to fill this gap. So the research question of this paper is simple. It is, are teacher effects, that is, do teachers affect all the students equally, or are teacher effects heterogeneous? That is, do teachers affect different student subgroups in different ways? So there are different reasons why teachers effects could be heterogeneous. It could be that the teacher may be treating some student subgroups.
Sorry, William. Sorry to
Yes.
interrupt you.
Yeah.
But we are currently seeing the first slide. I don't know if it's right or if you.
Do you see the motivation slide?
No, we see the
Oh,
first
okay.
slide.
Let me. Okay. So let me try it again. What about now? Do you see the motivation slide?
Yes.
What about this one? Do you see the achievement gaps slides? Okay.
Yes.
Thank you for letting me. So achievement gaps are important, and therefore the research question of this paper is, are teacher effects homogeneous or heterogeneous? So I was saying that teachers effects can be heterogeneous. That is like because it could be that teachers affect different student subgroups in different ways. So for example, a teacher may treat girls differently from boys, or it could be that teachers treat everyone equally, but there could be some match effects. So for example, there could be some role models. So if the teacher is a woman, girls would do better. So there could be different reasons why teachers could be heterogeneous. Teacher effects could be heterogeneous. So to fix ideas, this table shows the racial and gender achievement gap in my setting. So the first row is just the unconditional achievement gap, but the second row I control for the lag test score. So when I talk about achievement gaps, it's about column 2. So the black-white achievement gap is about 0.2 standard deviations, whereas the gender achievement gap here, we see that female has an advantage. So it's much lower, 0.01 standard deviation. So just have this number in mind, 0.2 standard deviations. So can you see my slide, this paper? Okay, so this paper, to answer my research question, I do the following. First, this paper, I document heterogeneous teacher effects. I start with the conceptual framework of education production function, where I relax how teachers affect students. So in this model, we have a student type specific teacher effects. So teachers may affect, for example, Black and non-Black students differently. From this model, a novel measure of teacher quality that I call revealed comparative advantage appears. And this novel measure captures teachers' impacts on a student outcome gaps. So it will tell me the differential impact of teachers on different student subgroups. I estimate this model using data from Chicago Public School in Chicago in the US. I have more than 1.7 million test scores. And I find that a standard deviation in this novel measure of teacher quality, a teacher who is one standard deviation in this distribution has an effect equal to 23% of the Black-white achievement gap. Then the second question, second, I test whether this comparative advantage measure is actually a good measure of teacher quality. So I exploit changes in teaching staff. So I exploit when teachers move from one school to another or changes from one grade to another within the same school, and test whether these comparative advantage measure are good predictors of teacher effects. So in other words, if I find a teacher who has one standard deviation in Black comparative advantage, I find that when that teacher moves to another school, Black students' test scores increase by one standard deviation, whereas the non-Black student test scores do not change. So the main finding is that the predictions of this comparative advantage are forecast unbiased. So they are good predictors of teacher effects. So I find that, yes, that comparative advantage predicts very well those disparate effects. And then third, I conduct counterfactual policy simulations to estimate efficiency gains of using this novel measure of teacher quality. So I conduct two sets of policy simulations. Due to time, I won't present these results, but let me summarize what I do. So one policy simulations is a teacher to classroom assignment where I reassign teachers to different classrooms in order to maximize those effects. And second, the second policy simulation, I follow the literature and I fire teachers who are the lowest performing and replace those teachers with the average teacher. So the difference between these simulations and traditional conventional ways to do this is that now we have one novel measure of teacher quality, which is comparative advantage. So when I include that new information, I find that there are potential efficiency gains, that is increasing test scores of about 8% if we include the comparative advantage measure in the ways in policy decisions. So that increase is equal to $10,000 per classroom. So the main takeaway of this paper is the following. First, I find and provide evidence that teacher quality has a general component that affects all students equally, and a student type specific component that affects some students but not others. Second, that value added, which is the conventional teacher quality measure, and comparative advantage, which is the novel measure of teacher quality, accurately predicts those components. And third, there are potential efficiency gains from implementing what I call heterogeneity-based policies. So this paper contributes to the literature. I'm gonna go very quickly on several domains. First, this contributes to the literature that talks about value added as a good measure of teacher quality. This paper adds comparative advantage as another dimension of teacher quality, and I find that that novel measure is also a good indicator of teacher quality. Second, this relates to papers that estimates teacher effects by student characteristics. So there are some papers that estimate teacher effects by gender and race, but those are observational studies. To the best of my knowledge, this is the first paper to quasi-experimentally test that those different effects are actually causal effects. This paper also relates to a student-teacher demographic match effects literature. So these papers estimate whether female teachers are better with female students or Black teachers better with Black students. Those are heterogeneity, group level heterogeneities. In my paper, I look at individual teachers. So I can estimate for each teacher who is better with female students and not. And lastly, this paper also contributes to the literature on match quality, since I quantify match quality between teachers and classrooms. So I'm gonna go for each of the different sections that I described. So the conceptual framework with the education production function. So I built on this paper, influential paper by Cherry et al., where they model a student test scores, YIT, as a function of an observable part that is captured by X. So that includes a student, classroom, and school level characteristics. And importantly, it also includes lag test scores. So this is measuring the change in the student test scores. And a student test scores is also has an unobservable component, nu, which in turn is also composed by an unobserved teacher effect, mu JT, which is allowed to fluctuate over time. So teachers do not have a fixed quality. That's an innovation of their paper. And other classroom level and individual level shocks. So using a student test scores output, it is possible to infer and estimate teacher effects. The innovation of my paper is that teacher effects, before each teacher had only one effect. The innovation of this paper is that teachers now have different effects that depends on the type of students. So now I allow students to have different types. So here only two types. So for example, female or male, or Black and non-Black. So teachers have two effects. One that is going to affect all the students from one type, let's say type 1, and the other effect affect all students of the other type. So that's the innovation of this paper, that I allow teacher effects to have multiple effects. So reorganizing terms from this heterogeneous value-added model, the second line, just reorganizing, I have that this unobserved component now have what I call the general teacher effect, or the general component that is going to affect all the students equally. And then the novel measure of teacher quality is this comparative advantage, which is the differential effect on one student relative to the other. So a teacher with a positive comparative advantage means that the teacher is more effective with type 1 students, let's say female students, relative to the average teacher. A teacher who has a negative comparative advantage means that that teacher has a comparative disadvantage or is less effective at teaching type 1 students than the average teacher. So with this result, now I estimate this model using administrative data from Chicago Public Schools. I have the universe of students and teachers from grades 2 to 8, so elementary and middle schools. And I have longitudinal data with about eight years. My main outcome, it is math and reading test scores. I have more than 1.7 million test scores. And the student characteristics are same as previous studies. I have race and ethnicity, gender, age, and other characteristics of the students. And I link students to teachers using the transcripts of the students. So I'm able to identify the math and reading teacher for each student, and then I link those. And I make some sample selection as previous studies. So this is the descriptive statistics of my sample. I have 326,000 unique students who appear in my data for 5 years. So half of them are female. They have an average age of 10, 11 years old. Only 10% of my sample are white, and 36% are Black, non-Hispanic, and 49% are Hispanic. So the majority of the students in Chicago Public Schools are minority students. So I'm going to split the sample into Black and non-Black students. So when I say non-Black students, have in mind that it also includes Hispanics and white students. Another important characteristic of my sample is that only 14% of the classroom has a student from both races, whereas for gender, I have that virtually all classrooms have students from both genders. So let me show you the distribution of the composition of the gender and racial composition of the classroom, which I exploit in my analysis. So on the left side, you have the proportion of female students in the classroom. This distribution is centered at 0.5, meaning that virtually every classroom has female and male students. So that is good for my estimation, because I can estimate for each teacher all those different gender specific effects. On the right side, you see the distribution of Black students. As you can see, this is a bimodal distribution where there's a large amount of classrooms without Black students and another large amount of classrooms with only Black students. But yet there are some classrooms that have both type of students. So despite of the differences, the stark differences in the distribution of female and Black students, I find that the results, whether I use gender types or race types, the results are the same. So using the data, then I estimate the model, and I estimate for each teacher their value added and their comparative advantage. This figure shows for gender types. So as you can see on the x-axis, this is the value added, the general component of teacher quality, and the y-axis, that's the comparative advantage measure. As you can see here, there is, for a given quality measure, for a given value added, let's say -2, you still find some heterogeneities in teachers' comparative advantage. So some teachers have positive comparative advantage and others have negative comparative advantage. So this is showing that there is some variation not captured by the traditional conventional measure of teacher quality. This compared to the next graph, this is by race types. The gender types is more compressed than the racial types. So the comparative advantage for race is more dispersed, and meaning that there are larger benefits from the policy simulation of teacher to classroom assignments. Next, so this graph shows the distribution of Black comparative advantage. This is just to show you that there's one standard deviation in this distribution is equal to 23% of the Black-White achievement gap. So I have 5 minutes left. So I'm gonna move on a little quicker. And so this table relates the homogeneous value added, which is how we are measuring teacher quality. This is the conventional way of measuring teacher quality. And I relate that with teacher comparative advantage and the reference value added, the two measures that appear in this in my value added model. So as you can see here, comparative advantage measure has a low correlation with the conventional value added measure of teacher quality. In fact, the reference value added has it's more highly correlated with the conventional value added. In fact, it explains almost 90% of the variation. When I compare column 2 and column 3, where I add comparative advantage, the comparative advantage measure explains very little the variation in conventional value added. So the point of this table is that there is some variation in comparative advantage that is not captured by a conventional measure of teacher quality. And I exploit that variation in my next, in the quasi experiment. So in the quasi experiment, the question is the following: is this heterogeneity in comparative advantage, is this because of noise, or is it actually capturing teachers' causal effects? So to answer that, I use this quasi-experimental design for teachers moving from one school to another. So this is the thought experiment. Suppose that in 4th grade, teacher A replaces teacher B at times 0. Okay, so this is the vertical red line. Both teachers have similar quality, similar general component, but teacher A has a larger comparative advantage relative to teacher B. So in the graph, I show this is a hypothetical example. I show the test scores of type 0 students and the test scores of type 1 students. So when teacher A replaces teacher B at time 0, the type 0 students, which is the blue line, we should not observe any changes in their test scores, but for type 1 students, we should observe an increase in their test scores. So this is in the graphical representation, I should observe an increase in type 1 test scores. So now I apply this thought experiment into my data. So I run the following regression. I have changes, across cohort changes in test scores. So let's use gender type. So I have changes in test scores for female students and changes in test scores for male students. My explanatory variable are changes in teachers' comparative advantage and changes in teachers' value added. So this is the regression that I run. And the identifying assumption is that changes in teachers' comparative advantage is unrelated to any unobserved changes of student quality, conditional on teachers' value added. And this identifying assumption is weaker than previous studies. So to finalize, let me show you this main table of the quasi experiment. So I have my dependent variable, it is changes in the student test scores. And again, my explanatory variables, if changes in comparative advantage and value added. So what you find here is that, let's focus on the third column and sixth column. So for Black students, the comparative advantage measure predicts almost one-to-one changes in Black student test scores, and the same as the teacher's value added. For non-Black students, I find that the comparative advantage measure does not predict any effects on non-Black students, whereas the general component predicts one-to-one effects. So in other words, the comparative advantage measure help us identify the teacher's causal effects on some students relative to the other. And I find similar results for gender types. So female comparative advantage helps predict the effects on girls, but do not predict effects on boys. So to finalize, coming back to the main research question, are teacher effects homogeneous or heterogeneous? I find that teacher quality has a general component captured by the value added that affects all the students, and a student type a specific component captured by comparative advantage. One standard deviation in Black comparative advantage is equal to 23% of the Black achievement gap. And in results that I didn't show here, another conclusion is that comparative advantage is a potential policy tool to improve efficiency in education and close achievement gaps. So with this, I finalize my presentation. Are there any questions?
So in terms of, so suppose two policies, one that attracts a good teacher overall, and one that attracts a good teacher in the sense of your new measure, right? Which policy?
So in the chat, okay, there are no questions for me.
Sorry.
There is
So I'm
one
happy
question.
to stay here. This is the end of the presentation. If there are no questions, we can end the panel.
Hi, William, can you hear us?
Oh,
Or,
oh,
your
my
audio.
audio is not working. My
Yeah.
apologies. I don't know why. Hold on.
Can you hear us now?
Okay, yes.
Okay, good thing that your mic was working, right? That wouldn't be a problem. Right? So I was just asking, suppose two policies, like one that attracts a good teacher overall, and another policy that attracts a good teacher according to your comparative advantage measure. So what would you like, or what would your model, what's your model prediction?
Okay.
What's the better policy?
Yeah, okay. First, well, I apologize. My audio was not working, so I apologize if I interrupted people. So can you ask your question again?
Okay, so so two policies. One, a policy that selects a good teacher overall. Another policy that selects a good teacher in the sense of your comparative advantage measure. So, what's your preferred policy according to your results, right?
Okay, so I think this is related to your question. So this is a policy that deselects the lowest performing teachers. So in the scenario one, I use the homogeneous value added, where only the value added measure, which is the first case that you mentioned. A policy like this has been shown to generate $250,000 per classroom.
Okay.
In the scenario two, now I combine this homogeneous with the comparative advantage measure. Okay.
I see.
And I construct this is an accountability measure that aggregates these two. And I find that the scenario two compared to the baseline scenario, I find that the test scores of students increase 2 to 4%, which is equivalent to 65 to 10,000 more per classroom.
Okay.
So combining those two measures yield better efficiency than using only one single measure. So I
Okay.
think that this is answers your question.
Yeah, yeah, that's interesting. Thank you.
Excellent. Are there any other questions?
Yes, sorry, I have one question. You were showing the graph about the distribution of Black students and that it was a bimodal distribution. So I was wondering whether your effects of the $10,000, it was 10,000, right?
Yeah.
Of the counterfactual policy, whether it might be driven by this bimodal distribution, because of course, if we reallocate teachers that are better for Black, then because of the distribution, we are going to have a big effect, because in the classroom there are a lot of Black students. So I was wondering whether your big effect is driven by that distribution.
Yeah, no, that's that's a great intuition, and that's true. So there are higher gains in the race distribution because of that. Because there are some teachers who are, let's say, in predominantly Black classrooms that would do better if we move them to other classrooms. So yes, you're right that one of the reasons I chose the racial distribution is because of that, because there are higher efficiency gains, potential gains when the distribution is bimodal.
Okay, thank you.
Excellent. So it's 11:20. I think we're 5 minutes over. Again, thank you so much, Grace and Jorge, for presenting.